A simple pendulum of length L is suspended from the ceiling of a car moving with a speed v on a circular horizontal rod of radius r. Find the tension in the string when it is at rest with respect to the car. Fine. What is happening is, let's say this is my simple pendulum and this is the condition. Fine. It is at its extreme position and G will be acting downward, that is the force mg, and then mv square by r will be acting outward direction, that is the centrifugal force, because the car is moving with a speed v in a circular track. Let's say this is my circular track, so mv square by r will be directly outward. Now as I told you, I have to calculate the tension in the spring. So what I'll do is, let's say this is my angle theta. Fine. So this angle is also theta, so t cos theta. This is my t sine of theta. So at equilibrium I can write t cos theta is equals to mg and t sine theta is equals to mv square by r. Fine. So just square both the equations. That gives me t square cos square theta is equals to m square g square, and t square sine square theta is equals to mv square by r whole square. So, and adding now both the equations, so I have t square sine square theta plus cos square theta is equals to mg whole square plus mv square by r whole square. So sine square theta plus cos square theta will be equal to 1. So t comes out to be under root of mg square plus mv square by r whole square. That is my answer for the first part. In the second part, I have to calculate the time period of the small oscillations. So as I told you in the previous question, that in case of simple pendulum, the time period is always given by t is equals to 2 pi under root of L by g effective. This g effective is the net acceleration of the bob. Fine. Now again it is very clear that g is acting downward and v square by r, that is the centripetal acceleration, that is outward. So g effective, that is the net acceleration, will be equal to g square plus v square by r whole square to the power 1 by 2, because they are at 90 degrees, so the resultant of both of them will be this. So I can just simply substitute this g effective into this equation to get the time period. So the time period comes out to be 2 pi under root of L by g square plus v square by r to the power 1 by 2. This is my answer.